Okay, so start sharing my screen. Can you guys see my screen now?
Yeah.
Yes, yes.
Yes.
Okay, all
Yes,
right. So we're
Yeah.
having 17 participants for today. That's interesting. And I'm happy to see that we have more guys who are eager to grow as developers, perhaps decentralized application developers. Let me put it that way, DApp developers. Okay. All right. So Solidity types. Solidity is statically typed language, which means that the type of each variable state and local needs to be specified. Solidity provides several elementary types which can be combined to form complex types. In addition, I think somebody's mic is not there. Who is that, please?
It's President.
Okay, I'm trying to mute the person now. Okay, I think he or she is muted already. Okay, so in addition, types can interact with each other in expressions containing operators. For a quick reference of the various operators, see blah blah blah. So you can go to the documentation and read about that. The concept of undefined or null value does not exist in Solidity. So what they mean here is that Solidity does not return what we call undefined, or it returns nulls. Because in JavaScript, when something does not exist, so JavaScript is return undefined for you, or return null. Okay, so these are error message that are returned, and Solidity does not have that. Otherwise, the only thing Solidity does is that when the operation cannot go through, Solidity will reverse it. Actually, when you use what do you call it, require function, it will reverse it to the previous state. So nothing will be changed in the AVM. So that is what the Solidity does. But newly declared variables always have a default value dependent on its type. So to handle any unexpected values, you should use the revert function. Please take note of this. To handle any unexpected value, use the revert function to revert the whole transaction or return a tuple with a second Boolean value denoting success. Okay, so let's begin with the value types. The following types are also called value types because variables of this type will always be passed by value, i.e. they are always copied when they are used as function argument or in assignment. They are always copied. So number one is the Boolean data types. The possible values are constant, true, and false. So what they are saying is here it is. But Booleans is a type in Solidity and perhaps in virtually every programming language.
50% or 5%.
Sorry?
54%.
Can you please mute the person? Can you mute the person? Can you mute the person, please?
Okay, let me check. Okay, I can't see him.
Kindly mute everybody.
Okay. So if you need to speak, you can raise your hand so I can see that. Okay, all right.
And please, your voice is a little bit lower. Please, if you can help us to increase the volume.
Okay,
Please.
all right. I'll increase my volume. Okay, thank you. Okay, I'm looking for the chat. Okay, all right. This is what I'm looking for, so that I can see what's going on. Okay, back to what we're saying. Booleans is what is a data types in Solidity, and it has a constant values. There are two basic constant values in Booleans, which is true or false. True and false. Sorry, it's either the operation is true or it is false. So, and operators that returns true or false value in Booleans are what? Are this logical operator. This is a negation operator, a negation operator, and this is an logical conductor. This is and this is or, this is equals to, this is comparison operator, equality or comparison, equality, and this is inequality operator. See, this equal and negator, what they call it, negation, logic negation is combined together to make inequalities. So the operators and can apply the common short circuit rule. This means that in the expression, in this expression, if f function value evaluated to true, dy will not be evaluated even if it may be side effect. Have side effect. So I will explain that with code now. Okay. Okay. So please, if you can't understand me or you can't hear me very well, let me know, please. So I'm going to open my remix. Let me reload that. Start now. I'll meet the person now. Okay, I think more people are joining. We're having more people. So this is my remix IDE, and I'm going to create another file. Create a new file here. Create a new file here. All. Oh my God.
So,
My
sorry,
God.
Mr. Bob, can you mute all
I've
in
mute
such a way that
everyone. It's those guys that are just coming in. All right, thank you.
Please mute Eric. Eric, he's on.
Okay, okay. Eric. Let me look for him. Okay. Okay. All right. So let me create a file. I'll create another file for today's lesson. I'll call it today.sol. So you can see it from here. So that's the file name, and you can make it a capital letter here. Today. Then I create that. So we have our ID here. We have our where we can write our applications. So where am I putting this? Okay, I think it's okay like this. Okay, so back to here. So let's start with explaining this with codes. And what this one is saying there is, what does this is Boolean operation, Boolean's data type, sorry. So, and we have two basic constants in Boolean, which is true or false. And what are the operators that return true or false in any in any data? How can I put it? Okay, what are the operators that return true or false? Engineer Samuel said it's blurring from my side here on my network. I think it's your network, sir. Please, any other person, is it blurring from your hand there?
it's actually fine.
It's
Fine.
clear.
Okay, it's clear. So I think it's your network, Samis. So let's continue. The operator. So I want to explain to you how to use the operator and, or, and this and logical operator. How to use them. So let us come here now. So if I create a contract, so let me say pragma. Remember your pragma statement. Pragma solidity greater than, or this greater than is not working on my PC. Let me just come here and okay. Greater than or equals to 0.7.1. What's that? Okay, I welcome the new guys that are just joining. Please follow us and pay attention as we code along. Then let's just use one compiler version. Let's just use one compiler version 0.7.4. Okay, so I'm going to create a contract. I'm going to create a contract called today's class. Today's class. Okay, this is our contract now. So in this contract, we're going to this contract, we are simply going to create a simple contract, and let's have data. And sorry, let me ask, what contract should we create? I'm having so many things in my head. Can somebody give me an idea or a start? What contract should we create so that we know what we are working on? We can't just be. Anybody wants to tell me something?
An agreement contract.
Agreement contract. What kind of agreement contract should we create? Okay.
Possibly business agreement.
Okay, let's just create a simple rentage contract. Simple rentage contract. Okay, a contract that tell the number of noise maker in a class with big head. This guy, so let's just create an agreement contract between let's say a landlord and a tenant. Okay, all right. So this contract is going to have what we call address of the owner of this contract. The owner of this contract will declare the address, and this address, let's make it public so that everyone can see it. We make it public so everyone can see the address. We declare it. So this address is going to have what they call okay, string call. Okay, sorry, by 32 agreement. Then please, I want you to pay attention to this, that we are working with data types, and remember that we are starting with a Boolean, and as we are coding along, I'll be explaining to you so that I will not be coming back to them. In this first the state variable that we declare an address type. An address type. This address is a what? Is a data type in Solidity. An address type, and the name of the of this variable is called owner. And we create a byte 32 of of the data type, and we call it an agreement. So in this agreement, we're going to create a function set agreement. So the landlord. So let me now put it here. Let me now change the contract name. Contract, excuse me, agreement. Set agreement. So here I'm going to call it landlord. The landlord, let's assume that the landlord is the owner of this company, the one creating an agreement. And this function set agreement, if we take in the address of the if you expect the address from the tenant, address underscore tenant, address of the tenant, and what other things should we okay, we're going to take in a price, okay, the price of it. And let's come here, let's create the landlord create a price for his house rent, and the prices of the house rent is this unit public, everybody can see it, public, call price, okay, all right. So that is the price. So now the set agreement Okay, then we set it to public. And this thing, because we are going to be setting sending values in the EVM, so we have to make it payable. We have to make it payable. And does it return? Let it return. Let us try and return what we call a Boolean value. A Boolean value called success. Okay. So if you come back to here.
Sorry, please, can you make the screen bigger? People are complaining that it's too small for them to see. Sorry for interjecting.
Okay, all right. Sorry, I'm not even paying attention to the chat. Let me see the chat now. Can you increase the character so that? Okay, sorry guys. I'm sorry about that. So I believe so you guys can see it now. So can you see it now? Is it okay this way?
Yes, it's okay.
Okay.
Yes, it's okay.
All right, great. So here I've created a function, and this function name is called set agreement, and it's expecting the address of the tenant that wants to rent a house from the landlord, and with a price that the tenant wants to pay. And in this contract, the landlord address, the contract can display the landlord address where the tenant can pay the money to. So we are going to say payable. We're going to call the address of the landlord payable so that he can receive ETA or BNB. And it has a price. And this price, the data type is called unsigned integer. And in this case, now we create a function called set agreement, and the address, and we set it to public. Anybody can interact with this contract, and it is payable because it will receive or send value. It will receive or send value. Then returns a Boolean called success. So now we are going to require, we're going to create so that our contract will be our contract will be somewhat safe. So we're going to require that this person that is interacting, who is the tenant, sorry, I've made a mistake here, address. Okay, we're going to require that because anybody who have an address, an Ethereum or BNB BSC address, can interact with this contract, and they might try to exploit the weaknesses in our contract. And we have to always pay attention to every weaknesses in our contract when we are creating it. Anywhere, any loophole that we see that other people might try to use against our contract. So in this case now, this person called tenant, if he does not have any amount in his account, then he might try to manipulate our contract. So we are going to ensure that this person has what we call the balance is enough. We're going to say underscore tenant, the balance of the tenant dot balance. Remember I told you something yesterday. This dot balance I'm using now, can somebody remind me what is dot balance? What does it mean? What kind of variable is? Please, I need interaction, please. I want somebody to remind me what this dot balance, what does it mean? What kind of variable is? I explained it on the group, and I explained it in the last lesson, I think. Anybody wants to try? Please, guys, let us try. Let us try. What is dot balance? What does it mean? What type of variable it is? Anybody want to say something? Nobody? Somebody said objects. Okay, sorry guys, it's not an object. This is a global variable, like I told you, it's a global variable in Solidity. It belongs to the Solidity environment, okay? So it is not custom to this contract. It belongs to Solidity global object. So that is why we are using. That means Any balance that this will return is not going to be a custom token that we create in our contract. It's going to be the global currency, which is available to every contract that are interacting with either Ethereum or BSC, Binance chain, Binance Smart Chain. In this case, we are interacting with the Ethereum chain, so we are going to be using Ethereum. So it means we are going to share the Ethereum balance of this person calling this contract. So underscore balance, underscore tenant dot balance, we want to ensure that is equal to that is greater than or equals to what? Equals to the price that we have set here. So no matter what it is now, this person, we are going to be assured that this person cannot try to manipulate this contract on that price. Okay, so where this now comes in, remember that we are treating this what we call this Boolean, and this is where we have this or and this negation contract. Now I'm still logic negation, and this or and. So let me now come back here. Sorry, wait, this one. So now we're going to be using and we're going to ensure that the address that is interacting with this contract is not an empty address, and we're going to say underscore tenants then if this is possible, then now let's come here. Now let's create an agreement and that we accept this offer from the tenant. Let's create a mapping data type, a mapping data type called address create it to mapping bytes 32. Sorry. Okay. Bytes 32 to the unit. Okay. All right. We'll call it agreement. Call it an agreement. Okay, guys. I've just created something here. So yeah, let me create it and I explain to you. Okay. Here I created what we call a mapping, because I want to create an agreement between the landlord and the tenant. And here we declare an agreement called, sorry, I'm not supposed to use this name. Let's say rent. Let me use this. Oh, rent agreement. Okay. Here there's a byte32 agreement. This is going to be something like a hash, and this agreement is going to put everything together and go to as in harmonize all the value between the landlord and the tenants, and you go to put it in one container called agreement. So, and in this mapping we use it to bond the agreement between the landlord and the tenant. So in this mapping, I have created something here. I created a key value, a key called an address, and the second key called byte32. And they are going to there are two keys in this mapping. Now we have the address and the byte32 type. And please pay attention. Mapping is is a representation of key value pair. So if you pass in an address and we pass in a byte32 object, it's going to return an unsigned integer for us. So now what I'm going to achieve here is this. if you pass in an address of any tenant and the address and the okay, sorry. Sorry guys, sorry, let me do it like this. Address so that it can be easier. By 32. Okay, so if we pass in the address of the landlord, we pass in the address of the tenant, then it's going to return the agreement between two of them for us. Okay, please at this point let me ask now, does anybody understand what I'm doing here? I don't understand, please let me know. Hello guys.
Yeah, what you are saying, to me, I really understand, but what you are
Okay,
heading to is,
and
I'm
don't
a
worry,
little bit confused.
you may not understand where I'm headed to. We are not, we'll get there soon, but I just want to ensure that
Okay.
you guys are following me.
We are trying to follow.
Okay, all right. I'm still going to come back here. We are not going to rush it so that you can understand. Okay, now let's continue. So let us now create an agreement between them. And I'm now going to say rent agreement. I'm going to use this variable name that is holding the, that is a reference, you understand, to the address ledger, to the agreement ledger between the landlord and the tenant. So I'm going to say rent agreement. Okay, and remember that this agreement is expecting what we call the first key should be what? An address type, and this is a data type. Remember, address is a data type in Solidity. So the first address now will be the address of the landlord. We are going to be passing the landlord. Then the second key for you to complete, the second key here is the address. It's an address again. So the second key will be what we call the tenant. The underscore tenant. Okay, so now we will now set it to the agreement between them. Okay, we now set it to agreement. So this agreement now, for us to create this agreement between them now, and this agreement has to be, the type has to be byte 32. It has to be byte 32. So excuse me. So I am going to say something like this. I'm going to use what we call ABI encode. ABI encode. I'm going to encode the address of the landlord. I'm going to encode the tenant, and I'm going to encode the underscore the price. Okay. All right. So then this will just return true, just return sources. Okay. All right. So I'm going to explain now shortly, but before that, let's see if there's any error in our contract. Please keep short. I mean, Crispy Short said I'm lost. Don't worry if you are lost. It's normal that you don't understand in the first place, and I will properly explain to you now. Okay. So now let's try to compile this contract. Let's see if there is an error. So I'm compiling. Remember, see, I'm compiling it here. So here I'm compiling it. So let's wait for it. It's still rolling. It's compiling. It's taking much time. It's not supposed to be like that. I think it's my network or something. Okay, now it said there is an error. Okay, here it said expected identifier but got payable address public. Okay, so now it's saying that this address will make error here. So let us remove that payable. So compile again. So it points us to another error again. Lost system doesn't may affect audio quality. Try closing some applications to improve performance. Okay, please, I hope you guys can hear me.
Yes, please.
Yes,
Okay.
you can.
Okay, all right.
Yes, we can.
So here the error we are getting here is this. It said type bytes. Type bytes memory is not explicitly convertible to expected type byte 32. Okay, so now what we are trying to do here is this. This is the error here. The error here says that I am assigning this the return value of this ABI encode, and this ABI encode return a byte object. And here, this I'm expecting this what we call byte 32 here. So I want to convert this byte to byte 32 here. It will throw error. So what I'm going to do here is this. I'm going to return this back to byte object. So I'll be expecting a byte object here and not byte 32. So I compile it again. So now it's compiled and it's showing us a warning. What is the warning here? So let's see what the warning is. The warning says, okay, SPDS license identifier. Okay, I do not like to see this. Let me try and something here. Where is this storage? Okay, this is what it's telling us. Okay, and this is what it's telling us. Let us paste it here. Okay, all right. So if you try to compile it again, where am I compiling? Oh, okay, let's compile that. So now it's showing green. Okay, fine. So now let me explain to you guys. So for those that are just joining us, I welcome you guys. So please pay attention. Please pay attention at this point. Okay. So what we are trying to say is this. We are here. We're trying to use this logic operator called or, then, and. We're trying to use this logic operator, how to use them. And this is the reason we are creating this contract. And in this contract, I create a contract called agreement. And this agreement is a rent agreement between the landlord and a tenant. And I will declare the address of the landlord here and the price of the house rent here, and which is public. Anybody can see it. So I will create a byte object, which we call it an agreement. Okay, we call it agreement that will serve as an agreement between the two parties. And we created to bond this agreement between the two, the landlord and the tenant. We are going to create a mapping. This is the mapping. And this mapping, remember the mapping, what mapping is a representation of a key value, a key and value. So when you pass in a key to mapping, it will return the value of that if that's a key has a value set to it. And this address is the number one key. And another mapping, you can have in Solidity, you can have what we call a nested of mapping, a nested mapping. What we are doing here is what we call nested mapping. We are nesting a mapping inside another mapping here. Can you see? This is one mapping here, and this is where it stops. And this mapping is taking in a key, an address as a key, and it's going to return a byte object to you. And we are creating inside another mapping. This is the outside, this is what outside mapping, and this is the inner mapping. Okay, this inner mapping, and we have a key, two key, an address, and a byte. Okay, now we create a function called address agreements. No, it's not going to be address agreements now. Set agreements. The function called set agreements. And this function is being going to create an agreement between the landlord and the tenant. So we are expecting an address called the tenant and the price that the tenant wants to pay for this house rent. And we set it to public, and the is displayable because it's going to be sending value, and we are returning what we call a Boolean value. And in this function, we check something called require. We try to check if the balance of this person calling this contract, the balance of the tenant. Sorry, let me not use this address of this. Let me use the person calling this contract. Okay, I'm going to be using the person calling the contract. So I'm going to be using message.sender.balance. Okay, so message.sender That is the caller of this person, of this contract. So we're assuming that the caller of this contract is a tenant who's trying to subscribe to our house. Okay, we are trying to check if the balance is greater than or equals to the price we have set. So that means the balance of this person must not be less than our price, the price or of the rentage. Then I say, and at the same time, and that is why this thing come here. And please pay attention. This and has to be two and at the same time, check if message dot sender is not equals to an empty address. Okay, so now there is no loophole to this contract. We are trying to minimize loopholes to this contract. That is what this and this is logic operator and means. So that means the contract will check this first condition, then again it will check this condition at the same time. So that means the two conditions must evaluate to true before it can execute this other code. Okay, these two conditions here inside this requirement, they must evaluate to true. So now let us run it. Okay, so let us compile it. I say there is an error again. So what is the error? Okay, underscore tenant. Sorry, we should not use tenant again. It should be message dot sender. Okay, so what is, I compile it again, error again. Okay, tenant. Okay, message dot sender. Okay, thank you. Okay, now you can see here that it is showing green on the left hand pane. So it's working fine now. So let us deploy it and interact with it. So you come here and you deploy your contract. But sorry, I'm not supposed to deploy this contract like that. I'm supposed to create a constructor so that we can know the address of this landlord. Okay, so we can set the address of the landlord. So let me create a constructor here. A constructor is going to pass in, is going to set whoever is deploying this contract, landlord is equal to message dot sender. Okay, all right. So now anybody deploying this contract will be acting as the landlord. So let us recompile it again. Let us recompile it. Okay, it's success. So let us deploy it. So that you can see it very well. I'm going to, okay. So I'm going to, okay, let me deploy it. So you can see now that is deployed successfully. Okay, so now let us interact with this contract. Let's come here. This is the contract on the left. So you can see the contract here. Can you see the contract here? This is the contract now, and this is the landlord, and this is the price, and this is the rent agreement. So here we can check the landlord. Who is the landlord? The landlord must be the person. It must be this address. It must be this address you are seeing here. This address are light here. It must be this address. That's the person that deployed this contract. So let us check. So you can see the address here. That's the address of the landlord. So now we are going to, this is the price. Okay, we didn't set the price. Sorry, we didn't set the price. We didn't set the price. I'm going to delete that very fast. Let us set the price to 2 eta. Okay, okay. I comply it. Okay, all right. So let me deploy it now. I redeploy it again. Success. So open the contract here. Scroll up. So this is the contract. Check the landlord. This is the landlord. And look at the price. This is the price. The price is what? Is 2 eta. Okay, now let us rent agreement. Let us create the rent agreement. We're going to be passing this person calling this contract. I will get the address of the landlord. of the landlord. Okay, I will pass in the address of the landlord here. I'll pass in the address of the landlord, and I'm going to use another address as the the tenant. Let me use the second address as the tenant. I will copy it. Okay, I don't need to copy it. I don't need to copy it. But here is expecting okay. Why is it showing this rent agreement should be one parameter? How come two parameter? How come two parameter? Should be one parameter. Okay, let me add this first. Okay, let me try to call it. So what is the return function? Okay, the agreement is created. Okay, the agreement is created. Let us check. What's the return function? What does it return? Okay, byte subject. Okay, all right, that's the output. So that's correct. So that's correct. Okay, all right. So do you guys understand now? Hello, guys. Do you understand what I'm doing?
I have a question. So,
You have a question.
No.
Who is that? Ojeme, right?
Yes, David.
All right, go ahead, please. Louder, please.
How can the landlord be message or sender and the tenant too in the function still be message or sender? It's kind of confusing.
Okay, all right. What we are saying here is this. The landlord can be the message on sender in the sense that the person that is deploying, interacting with that contract at that point in time, the person that is deploying that contract at that point in time is the message or sender. And the message or sender will change here when we are calling this set agreement. In the sense that if you remember, I changed the address here. I change it from the first address, I change it to the second address here. So the message or sender at that point in time change. Okay. So do you understand now?
Maybe I don't see get it, sir. I don't see get it.
You don't get it? Okay. All right. Please pay attention. So I am going to delete this.
Hello, may I finish, please?
Okay.
Can I ask a question, please? Okay, fine. What I think the best question that a way to say it is this: how do you know you are sending from the tenant to the landlord when there's no transfer to?
When there's no transfer to, right?
Am I making sense?
Okay. All right. So I think you understand. I think I understand you now. So now let's do it here.
Where payment is going to be confirmed, because
yes, that's the mistake I did. So let me correct it now. So now we are going to be I'm going to be sending, doing like this. Okay. Landlord dot transfer underscore price. Okay, so let's say the sender minus equals to message dot value. Okay, then landlord, oh sorry, I see message dot value underscore price. Okay, so landlord.transfer underscore price. Okay, now see, this is what you are trying to say now. Here now, I am deducting the amount, this amount here that we are passing in, I am deducting it from the balance of the person of the tenant. Then I am sending it to the landlord here. Okay, I am transferring it to the landlord here. Is that what you are trying to say?
Yeah, something like that. You are the boss. I'm trying to understand the code. You understand? But I saw that was missing. Yeah.
Okay. All right. Thank you for calling attention to that. I also didn't pay attention to that. So here we are trying to we'll be sending as soon sorry, we are not supposed to create this agreement now. We're supposed to be deduct that money first, then create the agreement. So now for this function to be, so let's create another agreement. Okay, so there's no need to create another agreement. I have set this agreement, I have set it to public. Okay, so as I set it to public now, it will return, so it will create a getter function for it, and we automatically become a function that we can call it using this key and this key. Okay, so now let us redeploy this contract. I'm going to redeploy this contract. Let me recompile it. So it's showing error. What's the error here? Okay, expected. Okay, here is the error. I forgot to put this in here. So let us compile it. What's the error here? Expression has to be an I value. Okay, message the sender dot balance has to be an I value. Has to be an I value. What's in here? Okay, guys, I'm getting error here. So I think I understand where the error is coming from. So I'm going to remove this here. Since we are dealing with the global objects, we are dealing with global objects. So let me see message dot the value, message dot the value, message dot the value, and here message dot the value. Okay, all right, so let me try and compile it. It's still showing me error. Please, does anybody wants to help me here? I think I'm getting error here. What's the error? What's the error? Okay. Okay. Let me see if this song will work. Okay. All right. I'm still showing error. What's the problem? What's the problem? The chance to be an operator not compatible with type address payable and U hint arithmetic. Okay. Type
Your
address
second bracket
you say?
should be after the sender. Your second bracket after the equal to should be after the sender. Address bracket message dot sender bracket dot balance. Just like you did in front. The second one after the equal to.
Okay. 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 I think I'm still getting the error. What's has to be an I value, L value. So the L value is saying is this address message dot sender dot balance. I don't understand. This is strange to me. Address. Sorry guys, we have to fix this. If you don't fix it, then there's no point. We're saying I value message dot sender dot balance. Okay, wait. Let me do it this way. Address underscore tenant. I'll get it now. Underscore tenant dot balance. Underscore tenant dot balance. Okay. So it's showing error again. Has to be an L value. Has to be an L value. Okay. 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 All right. So let's do it this way. Okay. All right. I think I understand now. Okay. So I get where the error comes from. So we can now use the message the sender. Message the sender the balance. Okay. So can you see now? So now I think the error is gone now. So the mistake I'm doing here is this. I am trying to assign to deduct, and I'm using a global variable here, which is message dot value and message dot sender. So I'm trying to deduct it and assign it at the same time. So this equals to is the one giving us error. But we'll get there later, okay? So if you check it again now, you see that it will show the same error. Okay? So the problem is this. This is the problem. There's a logic error there. So let me remove it now. So here I am simply deducting the message, the value from the balance of this message or sender, from the balance of this person calling this contract. Then I will be transferring this value to the landlord. Okay. So now if you compile it again, and it's saying send and transfer are only available to objects of type address payable. So what is the problem now is the address of the landlord is not payable. So here we are going to say address payable. Let's see if that should work. Okay, so that will work now. So before you know that I created a payable here, but what I did was that I added it. So some places you might get error sometimes. I added it after the public, after this visibility. That's I added the payable. So if you compile it now, it will throw error. Okay, so now that means this one has to come. The payable, this visibility has to payable has to come before the visibility. So compile it again, it's gone. Okay, so now let us deploy this contract. Let us deploy this contract. I'm sure we don't have that contract running already. So does anybody saying something in the chat? I ask because the way you write the code from bottom to top and to bottom and sideways, just curious. Okay. Yes, I have a question. There are steps required to follow when creating the smart contract. Yeah, there's a step. So, and the step is that I will show you the template that you have to follow, and you just have to understand the data type first. So let's deploy this contract before I explain. So here is our contract now. Let's open it. So this is the contract here. So this is the landlord. Please pay attention. This is the landlord, and the person who asked me the question concerning the message dot sender. The address of the landlord is the person that deployed this contract. And remember that I have not changed this address. This is the address. This first address here is 0x5b3. Okay. No, the second, the second address is 0xab8. 0xab8. Can you see? 0xab8. That is the deployer of this contract. Okay. So now let's check the price. This is the price, 2 hectare. So Let us set the agreement. Let us set the agreement. So what is agreement? What is it telling us now? The set agreements. You say bool success first. Okay, but set agreement is not supposed to go through. It's not supposed to go through because we have not set the value here. We have not set the value here. And it's saying that require that the balance of the message to sender is greater than or it is equal to the message dot value. Oh, balance of sender is not message dot value, sorry. Price. Okay, that is where the error is. So compile again. So let us deploy it. So come here, open the contract here. So set agreement. This one you should set the agreement now. You should throw error. It's going through. What's going on? Set agreement require that the balance message dot standard dot balance is greater than. Okay, all right. Sorry, you are saying something. Your network is bad. I cannot hear you, please. Hello, Adeniyi. I cannot hear you.
I said I think the tenant. I said I found that's why the has more than 2 Ether in his account. I think that's why the contract is going.
Exactly. Thank you very much. Because this is the sender now. The message the sender has more than that, but I'm not supposed to be using the same address that creates this contract. Let us ensure that the person that is calling this contract is not the same address that deployed this contract, because now it is going through. So I'm going to make another requirement statement. Require that the message the sender is not equals to. Okay, so here I am using equals to. I am using a negation, a logic negation here. It's not equals to landlord. Okay, it's not equals to landlord. So compile it here. What's it? Unary operator cannot be applied to why the message the sender okay, all right. It's supposed to be here. Message the sender cannot equal to landlord. So let us deploy it now. All right. So here is our contract. Open the contract here. So you come here. They are trying to set the agreement now. Okay, I have deployed, and this is the address that deploy it. Okay, let us try to set that agreement, whether it will go through. Can you see now? It shows us an error here that the transact to agreement error. VM revert the transaction has been reverted to the initial state. It's not going through, and this is the reason. The reason is okay. We did not provide the reason, so it will not tell us. So now I have to switch back to another address. Let me switch back to another address. So another address is acting as the tenant. So let us create an agreement. Let me send to Ether, and I'm going to to Ether set agreement. Okay, can you see now it is success? So now if you see agreement now, let us now go to the rent agreement. Remember that here I have created the rent agreement here. So if you come to this rent agreement mapping now, okay, and this is the mapping, and it is public. as it is public now, we not create any function for this, but Solidity create a getter function for it here. So now we're going to be getting the agreement between the landlord and the tenant. So let me paste the address of the tenant. Let me copy the address of the tenant here. I'll paste it here. So let me get the address of the landlord. This should be the landlord, the second address. I'll copy it. So I'll paste it here. Okay. So now let us call it. So now you can see what the return function here. You can see it here. So it means this is the agreement. Now this is the representation of the agreement between the landlord and the tenant. Okay. All right. Let me now explain to you now. We have been able to achieve what this and logic and operator. Logic operator call and then again this logic not equals to, like we have in the solidity here. That's how to use it. Now we are able to use this one. Okay, we are able to use this one. Then we are able to use which one again? The inequality sign. The inequality sign, and that's the one we use here. We make sure that the landlord is not equals to the message or sender. That is inequality sign. And here we check that these two conditions, message or sender, the balance of this message or sender must be greater than the price we set. Okay, then please guys, just a minute please. Okay, all right. So then another here we check that the message the sender is not equals to an empty address. This is how you can achieve and you can use what we call the logic operator. So do you guys understand now? Please, any question here? The target of this whole is transaction is for us to understand how to use this inequality logic operator, then this AND operator. Please, anybody does not understand?
Yes, please. Just can you kindly say, repeat again, the logic, the AND, the double AND logic there.
Yes.
The function, it works. I completely understand the negative logic. Yeah, when it is not equals to. But for the AND there, what does it imply? Please again.
Okay, this this AND implies that when this condition, this is a condition, okay? This is the first condition, and this condition states that the balance of the message to the sender must be greater than or equals to the price that we have set. That is the first condition. So either we check this first condition. After he check it and he comes here, he saw this and this and tells the solidity that again at the same time check this condition that the condition is true. That means that this all two condition has become one condition. That these two conditions now must be equals to true. We are conjuncting it together. That means we are joining together. These two conditions must be true. Do you get me?
Yes, please. Yes, please. I understand. Right. So in that regard, it means that, sorry, let me just repeat what you said. In that regard, it means that the two conditions must be met.
Must be met.
Or become true.
Yes.
Exactly.
Exactly. Before the other code can be executed. All right, I like that. So now let us use the OR operator. Let me show you the difference between AND and the OR operator. This is the OR operator sign. I have changed it from the hand. Remember, I have changed it from the hand. So this is the OR operator, the two pipe symbol. Okay. So now, if you run this code, here it tells you that either of these condition must be true. Okay. Or that means or this is true, either this is true, execute the code, or this other one is true. Okay, he said that any of these condition must be true. So if this one is true, if the first condition is true, it will ignore the second condition. It will not check it. Okay, but if the first condition is false, if this one is not true, it will go to the second condition, it will check whether it is true. And when it is true, it will pass on and execute the rest of the code. But if the two conditions becomes false, then it will revert. Then it will not enter here. It will revert. Immediately it will break and it will revert all the changes to the state. Do you understand me, please? Anybody does not understand that? Please, I need answer, please. At least one or two person.
Yes, it's clear. I understand that now. Thank you
Okay.
so much.
It's clear.
All right, great. Thank you very much. So let's quickly move to the other one because I'm not going to spend much time today. So integer, we have int and we have unt. Integer and unsigned integer. So the first one represents a signed integer, the second one represents unsigned integer. You can see there signed and unsigned integers of various sizes. It can be of any sizes, but a lot of mostly it has to be unsigned integer has to be of 8 up to 256 bits. 8 up to 256 bits. That is what it means, and this is like 2 raised to power. Okay, these are 2 raised to power. Where's my? And this 2 raised to power 2. Sorry, 2 raised to power. I think 256. Is it 256? Yes, I think 256. Okay, 256 minus 1. No, 256 minus 1. Okay, this is what it means. And please, we may not go here today, otherwise we will not leave here. So I need you to go online and read about these bits, how to convert bits to bytes. What does it represent? You understand? So that you can have more understanding of what it means. So here it says an integer 8 to int 256 and so on and so forth. So when you come here now, you say comparison. This symbol is used for comparison, and this one is less than, this is less than or equals to, this is less than, this is if you guys cannot see it, okay, let me zoom it. This is not equals to, and this is greater than or equals to, and this is greater than. This is a bit operator, so you can go there and check it, and that is integers, data types in Solidity. And if you come here, another one data types in Solidity is this address. Like I told you the other time, address is a data type in Solidity. And you say the address type comes in 2 flavors, which are likely identical. So address, a ordinary address, and address payable. This address also, this first address holds a 20-byte value size of an Ethereum address. So if you come here, let me explain to you here. Remember, like I told you here we specify an address. This is an Ethereum, ordinary Ethereum address, which is 20 bytes. Okay, and this address is not payable. And that this address is what is referring to here, the first address here. So there is no way you can set, in the recent Solidity version, there's no way you can set Ether to or BNB to this address. To this address here. There's no way you can set it to this address. So sorry guys, there's no way you can send Ether to this address here because the address is not payable. But soon as you make it payable here, you can set Ether to it, and that is what they are referring to in this documentation. This is an ordinary Ethereum address, okay? And in the latest Solidity version, Solidity regard an address type without a payable as an ordinary Ethereum address with 20 bytes. And when 20 bytes, what does it mean for address to be 20 bytes? Let me explain to you. Okay, where is our IDE? So you come here, let me copy this address here. Let me paste it here. Let me paste it here. Okay, I'll remove this. I'll set it to here. Okay. Okay, so let us count this now, guys. Let us confirm that this address is a 20 byte, and 2 characters make a byte. Okay, in the Ethereum, these 2 characters here. Somebody is saying something. Okay, all right. Oh, no. Okay, so if you remove this OX here, this OX here is prepend. I'll remove this OX here and let us count it. Okay, this is 1, this is 1, this is 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. So this is for 40 characters, and 2 characters make a byte. These 2 characters now make a byte. So this, if you divide this 40 by 2, it will give you 20. So that 20 is regarded as 20 bytes. That is what it means. So now to make it a valid Ethereum address, now you have to prepend it with this OX. Okay, it's an hexadecimal, so OX, and that is what they are trying to say in that regard. So we come back here. That is what it means here. So address payable is the same as address, but with additional members, transfer and send. So that is what we are trying to do in the other place, that we are trying to send it as it's not going, except until we added this payable to it. So you can go through that and read more about it. So another data type in Solidity is this. Let me go down. Address literal, that's long. Okay, this is another data types in Solidity. It's called Enorm. Please pay attention to this. Enorms. How do you declare enorms in Solidity? So it's a enorms are one way to create a user-friendly types in Solidity. They are explicitly convertible and from all integer types, but implicitly conversion is not allowed. Okay, let me explain. The grammar seems to be too much. Okay, let us declare an enorm here. How do you declare enorm? You have to use the enorm keyword. Enorm keyword. You call it let's say enorm call it stages. Okay, so stage 1 may mean begin, and stage 2 means that ongoing, and stage 3 means that end. Okay, you have to use capital letter, begin. Okay, this is an enorm. Please guys, pay attention. This is how to declare an enorm in Solidity. And this enorms is a data type in Solidity. It's a way of representing some numbers, some string that are mapped. Automatically they are mapped to what we call integer. So this first one will be representing 1, and the second one will be representing 2, and the third one will be representing 3. Okay, so now for you to now declare this enorm, you can now say it's just like a contract, or like a class. Stage. You will use the enorm name stage, and you create an instance for it. Stage. Let's call it stage. Okay, let's use my stage, or item stage, or whatever. Item stage. Okay, so and you can assign the first automatically this one by default. The value of this by default will be the first value in this object. The value of this item stage variable that will create an instance of the stage, the value will be the first item in this thing. So you can now use it in this contract. Now you can now say, you can say stage, sorry, is it my stage? Okay, item stage is equal to you can now put it to what, you can set it to what we call item stage two. So let me try and compile this. Okay, it's showing error. What's the error? Send and transfer are only available to objects. Okay, here is the problem. Okay, yeah, what is it saying here? Type is not callable. Okay, you say type is not callable. Okay, so let us use ongoing. So compile, it's showing error, undeclared identifier. Okay, all right. So let me not go to this now. We'll get there later. But what I'm trying to do for you is how to declare Enorm. Okay, how to declare an Enorm. So please, who does not understand how to declare an Enorm, please? Please, are you guys paying attention to me? Are you there, please?
Yes, we're there.
Okay, all right.
We get it.
Okay, all right. Thank you.
Not so clear for the enum, though.
Sorry?
Not so clear for me, the enum.
Okay, the enum is not so clear for you. So if you look at here in the enum, if you look at the documentation, it said the enums are one way to create a user-friendly type in Solidity. They are explicitly convertible to and from all integer types. That means you can convert from an integer to whatever object you pass in as an enum state. It's not, I'm sorry, from all integer types, but implicit conversion is not allowed. That is what I was trying to do the other time. The explicit conversion from integer checks at runtime that the value lies inside the range of the enum and causes a panic error. Okay, otherwise the enums require at least one member. That means here at least it must be, it cannot be enums here. At least this is what, compile it. So can you see now error? Variable struct modifier declare expected. Sorry, it's not supposed to be there. What is it? Okay, all right. So what I'm trying to say here is this. They are trying to say that in the enum object, it must contain at least one member. At least one. That means if you pass one member here, it is valid. And if you put begin, ongoing, end, it is valid. Okay, so that is what it's trying to tell you here. That is what it's trying to tell us here. So it said the data types representation is the same as for enums in C, that means C language. The options are represented by subsequent unsigned integer values starting from a 0. So if you come here now, if you try to check now, look at it here, look at this contract here. It says declare an enum, and the enum name is called action choices. And the action say you can either go left, or you can go right, or you can go straight, or you can sit. Okay, so if you come here now, let us remove all these old contracts. Let us try to create what an enum is. Okay, let us declare an enum called state. The first stage should be, let's say if you are starting, for example, you are starting a game now, and the game is just let's say the game is Okay, begin, just begin, and it is ongoing, and it has ended. Okay, all right. So let us now create a struct for here, struct game. And in that struct is holding arbitrary data type. Okay, so in that struct we have an integer called we have state called sorry, we declare an enum state called state. Okay, state, and assign, let's say, integer of counter. Okay, so let's compile it. What does it say? State. Okay, all right. So here we declare a struct called game and the enum state. So now let us create a function. I want to explain to you how to use enum function. Start game. So that's game is public. Okay, it's public. So now we're going to require we're going to require that this game struts. Let me game, an instance of underscore game. Okay, all right. So require that underscore game dot state is equal to 1. Okay, otherwise say that game already started. Okay, then otherwise then you continue. Then you can now set underscore game dot counter plus so equals to 1. Okay. Then underscore game dot state is equal to 2. Okay. Okay, what does it say? Okay. Game storage. What is it saying? Time enum. Sorry guys, trying to let me write this in finish so that what's the problem? State is equal to state 1. state what is state ongoing. What's undeclared identifier? Sorry guys. Okay, let's go game the state. Want to increase this one. This is an integer, so it's supposed to be state. Okay, state. Okay. So guys, let us check this thing. I think I'm trying to see how I can increase this action choice. Okay, change constant default dot go straight. Okay, this is what I'm supposed to do. State dot ongoing. Ongoing not visible after argument lookup in Enorm state. Action choice. Okay, action choice that goes straight. Okay. Choice, okay. It's declare here. Action choice constant default choice. Okay. Choice is equal to action choice that goes straight. Okay. All right. So let me just come here. Let me move this. Let me move this down here. Let me move this down here. Dot begin. Then require that game the state is equal to state. Okay. So then the state is equal to state dot ongoing. So this is where we're having the issue now going on for after argument. Why is the problem? Look up in state. What's the problem? It's supposed to work. Action choices. This is action choices. Dot go straight. Dot go straight. Okay. Hello guys, sorry, are you there with me? Please, are you following me?
Yes, we're here.
Okay, all right. So I'm trying to solve that. It's sometimes it's very confusing. So because you have to create the instance, I've created an instance here. This is the instance, and this is the variable. Sorry, this is the variable. This is the name of the instance, and we are setting it to the state dot begin, which is the begin. So it will be a default value. Okay, this is the default state. Let's call it a default state. Okay, so that's the default state. So now we require that the state of this game, here, yeah, should be default. Should be default state. Okay, so to be default state. Okay, then we are trying to set it to ongoing here. We're trying to set it to ongoing. So and if you come here, what does it tell us? They are using the same thing. So we are using the same convention. So it's supposed to work. Let's see where the issue lies. So now underscore game dot state is equal to state. It should be state. It should be state. Which is this? It should be state. Which is this? Dot ongoing. So this should work, and I don't know why it's storage pointer can be accessed without prior assignment. Which could lead to okay, underscore game default state. Okay, underscore storage is equal to let me use okay. That's it. It's equal to that default state. Default state. Okay, all right. So guys, sorry, there's a slight this I'm trying to fix there. So if you come here, you see now we have declared the enum state here, and this enum state now we say the game can either begin, or it is ongoing, or it has ended. So this Solidity will create a what you call a mapping automatically on the underground. It will create a mapping of integer, and the integer this one will be 1, integer which one will be 2, and integer this one will be 3. Okay, so states we're now declaring, creating an instance of this enum, because we're using capital letter here, so it's more like a class. Okay, so we are creating an instance of this enum, and we are using the name enum state, and we are creating a variable called default state that will hold the value. That's the default state we are setting it to begin. And that you can actually create the default value to any of these value here. So and in this function now, we are requiring that the first state should be the first state should be default state. Okay, the first state okay, I think yes, it's correct. Should be the first state. The first state should be begin. Then we now set the default state to the state ongoing now. So if you run this code now, it will run, it will compile successfully. This is how you can declare an enum, and this is how you can use it. I will show you how you can use, because I don't want you to confuse us, okay? And because of our time, how you can use a state struct with a enum. I will show you when we get to the struct data type. So please, anybody has a question in this regard? So we have like 30 minutes more to spend. Anybody with question, please? Okay, thank you, Jonathan. Thank you. Yeah, I just saw that now. Characters make a byte. One thing I have learned: 2 characters make a byte. Yes, 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 yes. So anybody has a question before I continue? Okay, if there's no question, let's just continue. So I want to cover the data types. We have covered the enums. So let's move to another one. Let me check for another one. Arrays, how you can use an arrays in Solidity. Okay, so arrays in Solidity, let me clear this one. Array in Solidity can be dynamic, and it can be a fixed size array. Okay, so how do you declare a fixed size and a dynamic array? So now we can want to create an array of u integer, unassigned integer. Let's say, for instance, we create an address, a counter call, we set it to 0, and we now create an array of we'll call it let's call it age. Okay, let's call it age, and you can see set this to public. Okay, because let us compile it now. Okay, you can set it to public. Please, this is what we call a dynamic array. Okay, this is what we call a dynamic array. A dynamic array, the size can change at any time. The size can increase, it can decrease. You can remove, you can add more than any, as in any value inside the array with no limit. Okay, so that is what we call a size array, and this is how to declare an array. We declare an array of unsigned integer. So in this array now, you cannot add anything like a string or byte 32 type of data inside. You have to specify the data you want to pass inside. It's not an array that can take in an arbitrary value. Okay, it can only take in a specific value and not arbitrary value. So this can only take in a value with that are unsigned integer. And if you want to take in a value data that has word that are string, you have to specify it like string. Okay, string public, let's say names. Okay, call it names. So you can declare it by 32 bytes array, bytes array of public, and you call it let's call it ashes. Let's call it ashes. Okay, so we can also declare by 32 array, by 32 array of any size, or you call it my bytes. So if you compile this now, they are compiled. Okay, this is how to declare a dynamic array. Dynamic array, as the name implies, if you look at it, is the word English. Dynamic means something that can change, that is not what is not constant. It's dynamic in nature. That is what array. But that is. Let me put it here. This is dynamic array. Okay. So, and this is fixed size array. How do you declare fixed size array? All you need to do here is just to specify something 4. Okay, 4 age. So what this one is telling us is this. Look at it here. Here I did not pass in anything here in this bracket. Here and it's only in this square bracket. In this square bracket here, I pass in an integer of 4. Okay, that means that this array, anything that I want to pass in to store in this array, cannot, the size, the length cannot be more than 4. That is a fixed size. I am fixing the length to 4. I am restricting it to 4. It cannot be more than 4. And here I can decide here. Let me copy this. Here. If I put it here and I say 5, that means I am restricting anything that this data, the size of this array to 5. This is it. If you okay, I think there's an issue here. What is it saying? Declaring error already declared. Okay, because I already declared, let me call it student age, and let me remove s from here. Let me call this one name. If you compile, that should work fine. Okay, all right. So that is the difference between a dynamic array and a fixed size array. So I believe you can declare a dynamic and a fixed size array now. Please, any question on that? Any question, guys? Okay, somebody has a question. He said, you have a question. Who is that, Michael?
No. I don't have any question. I'm just
okay, all right.
Trying to.
Okay, all right, great. Anybody before I proceed? Okay, all right. Since there's no question, let us move to the next data types. We are done with array. You can go there and read more. Let's see the other data types. Okay, structs. Structs is very, very important. You have to pay attention to how to declare structs. And it says Solidity provides a way to define a new types in the form of struct, which is shown in the following example. So, structs, a struct is it takes in an arbitrary data types. Okay, you know that in an array we can only pass in one data type. So, but in the structs, this is how you declare structs with the struct keyword, and you give it the name. Structs, let's say students details. Okay, and this is how to declare structs. You have to use the curly brace, and you have to use here. You have to use a capital letter. Students detail. That's how to declare structs. And in this struct, you can take in arbitrary value, and you cannot assign a value in a struct. You can only declare them and assign them later. You have to say, let's say the name of a student. That name will be a what? String. His name. Okay. Student has an object name and a property name. Then he has an age. Then he let's say string color. Okay, then a student can have what we call mapping. This mapping, and student can have an address that is mapped to this my what do I let me come here and copy this thing. This is what I want to copy. Okay, map it to what to bool, and we can say it's a student. Okay, is a student. All right, so this is correct. Okay, this is what we call declaration, and if you compile it, this will run fine. So this is how to declare a struct value. It takes in arbitrary value. Arbitrary mean by that means any type of what any type in Solidity can go in the struct. Okay, it can even contain a struct can contain a struct of itself. A struct can contain, I can say a struct, a struct classroom, class A. I can say a struct class A. I can say a struct class A, and here in this student, I can declare that struct that class A, student class. I mean the class the student belongs to. It belongs to class A. Okay, so you can declare. So if you compile it, what is the problem here? Okay, that means there's nothing. I have to put something. Let's say I call say string students. Okay, all right, so that should work fine. Okay, because it must contain something. You cannot leave it empty. So this is how to declare a struct and how to use struct. And this struct is like a class, like you declare Enorm. It's very resembling, or sorry, it has the same resemblance with Enorm, except that the keyword is called a struct. And if you look at Enorm is using the keyword Enorm, and we say state. Okay, and we use the curly brace, and we say begin, ongoing. Okay, all right, so that is the difference there. If you compile this, that should be fine. Enorm, and it's capital letter, and it's followed by curly brace and the content inside. Then struct, also struct keyword, the same pattern, except that this one cannot take in arbitrary value. Okay, this one takes in arbitrary data types. Anybody with question here before I proceed? And please note that here you cannot assign this in at construction time. You try to assign it that my student, his name is what is let's say his name is Jake. Jake. This will throw error. Can you see? It say expected this but got this. So it start to tell you that it's not expecting you to assign value. It's just waiting is only for declaration, declaring the type of value you are going to assign to them in the future. Is that okay? Please, any question here? Any question here, please? I have a question, please speak. Hello guys, any question?
For me, not really. I don't have any question. The only thing is that my head is doing me like where they are frying popcorn.
Where they are frying popcorn? How? Because
you know, when you fry popcorn, it will be like.
Okay, I understand. I do. Is it strange to you? Is it strange to you, or like too many?
So my head enough for the day. I'm thinking.
Okay, you have enough for the day. Eh? We are just trying to cover the data types so that in the next class we're not going to be working on the data types again, and we assume that everybody understands what data types, so easy data types is. So that is why I'm trying to quickly cover that. There is a lot to explain, but the thing that is that I have to also ensure I manage the time, but I have to also be sure that you understand because we are dealing with the basics. So the last one here.
Okay, sir.
Sorry.
Okay, real quick, please. Let me just say this: if it's possible, maybe prior to the next class, so we can have these docs. So you can tell us the particular doc we should go and look up and see, like in preparation to the class, and what we're going to talk about, and the doc, so we can read it, have like at least a basic sense of expectation of what we are going to do. So it helps us in the understanding while you are explaining.
Okay, all right, great. I will do that, but I also did that because I already mentioned it on the group what we are going to be discussing on, and which I told them is the Solidity Data Types. Even somebody even suggested it before I said, okay, that is what we are going to do, and I believe that everybody have everybody understand and know ahead of what we were going to discuss. Okay, but I also put that into notice and I'll work on that. All right, thank you. So the last one but not the least, and I think is mapping. Mapping types use the syntax. This is the syntax of mapping. You can see mapping, this is the mapping keyword, and it takes in the key type and it will return the value types. This arrow here means return. It's just like a function that returns something. Okay, that takes in something and return something. That is what it is. So we are mapping a key type to a value type. So what it means is that you are not using the actual key here. You are only using the type. You are specifying the type at construction time, and you are going to specify the value type as construction time. So let's come here now. Let us declare a mapping. And this is the key type. And the key type is that we're going to take in address type, which is type. Okay. Then the value type is going to be what we call. So, and remember this, please note that this mapping can take in any can take in almost any type. Okay, you can use this student detail. We can use it to be the value of this type. Let me use student detail. Sorry, it's not student class. Student detail. No, what's going on? Okay, all right. So we'll call it students. We call it students. So if you compile this should compile fine. So let me explain to you what we did here. What we simply did here is this. We create a mapping, is that a key value type and an address. We're expecting that an address, when you pass in an address, it will return this student struct for us. And this student struct is containing several details. These are the details that are contained in the student struct. So if you map this to this, it will return this for you. Okay, so we are using the students struct here. So, and if you let us create a function as the last, a function that will return that for us, let us call it a get student. No, sorry, create student, and sorry, address underscore student, and string memory name. Okay, remember that this data here, because we want to create a student, so we'll be expecting this data, we'll be expecting all this data in here. So the class student, this name here, then the age will be unsigned integer. Remember, it is an unsigned integer here, and you have to specify the type here, underscore age. Then the string, let me just remove this one so that we will not have too many. Let me just remove this one. So that is what we are expecting. So say returns, and here remember that we are going to be returned, we are going to be returned. We want to get the student details, which is the student struct. And for you to specify the return type here, you have to use the student, you have to use that struct name. Then you say memory, sorry, students, and you create this thing for it, a variable called student underscore, let's use underscore student. Okay, all right. So if you compile this, it shows us error. But let us see what the error. It said no visibility specified. Did you intend to add public? Okay, let's make it public. We didn't add visibility public. Okay, what other error again? Let's see. It say identifier already declared. Students. Okay, identifier already declared public returns. This thing is blocking me. The previous declaration is here. Address underscore student. Okay, I think this is the issue here. Let me just use that word. Okay, so what is now the last error? Data location must be memory, and here must pass memory. Okay, string memory address students age. What's the issue there? Say types contain nested mapping, can only parameter return variable in internal library. Okay, it returns, it contains a nested mapping. Let's remove this one, we don't need it because we already create a mapping outside there. Another error, this type is only supported in ABI v2 Pragma ABI Coda v2. Okay, Pragma ABI Coda v2. ABI Coda v2. Syntax unknown. Okay, how do they declare that ABI coda here? How do they declare ABI coda here? Okay, I can't get that. Let me just use let me just, okay, the return value will now be class class A, then string, these are the string memory. Okay, these are the data that we're expecting. Then unsigned integer age, unsigned integer. Okay, all right. What is the issue again? On the memory class A. Forget this. Oh my god, this is type is Let me just simplify it. Okay. All right. So now we'll now say class A underscore student underscore stud is equal to students message the sender. See the sender. Then we now use we create. Remember what we did here. Please know what we did here. What I'm doing here is that I want to create a student, and for me to create that student, these are the information I need. I need the address. Remember that we need the address here. We map the address. The address, when we pass in the address, it will return the student details for us. So we need the address as the key. So we need the address, and we need the name, and we need the age. The name and the age. So that is how we are passing it as parameters here. And we are saying that it will returns, these are the type that it will return. It will return a string memory type and unsigned integer. It will return two details for us, this one and this one. Okay, so now for us to now set the student, we need to create an instance of this student because it's capital letter, it's more like a class. So we are creating an instance of it. We are saying, sorry, not class, is student. I'm supposed to use the student detail, a student that we want to. Okay, all right. So now we are going to be using this underscore stored now, is the one that is representing the instance of this class. So that we are using this underscore to access the members of these students detail. So it will access this data for us. So we are going to say underscore stored dot name is equal to whatever we pass in as underscore name here, as underscore name. Okay, all right. So underscore stored dot age is equal to underscore age, whatever we pass in as age here. Okay, all right. So when we set something like this, it's already set, and we can now okay, all right. So but first let me just do something here so that let me create student detail, say it is public, and I call it that student list. I'll call it student list. Okay, all right. So here we create a dynamic array here. A dynamic array in the sense that I didn't pass any, it's not a fix. Okay, so we want to store, this is acting as a list, and this is acting like a hash mapping. This is not a list. Okay, don't get it confused. This is not a list, it's like a hash mapping. But this list, you can iterate this list. This one you cannot iterate on it. You cannot use a for loops on this mapping. It is not possible. You can use for loops on this student here. Okay, so we are going to be, this is an array, and for us to add something in the array has a member called push. We are going to be using the student's name, the student list dot push. When we are going to be pushing this on this instance. This instance now is having these two data. So we are going to be pushing these instances inside this array underscore stored. Okay, all right. So that's correct. So let us compile it. So it's giving us error here. So what is the error? Say students. Okay, we have to specify the location. It's storage. Why it is storage? Let me explain to you. Hello guys, are you there? Are we sleeping? Are we alive?
Yeah, we're here.
Okay, all right, great.
We are
So
here.
let me explain the difference between memory and storage here. Okay, So you know where to use memory and you know where to use storage. This student's detail, this student's struct I declare here, it is existing in the EVM, in the blockchain. It is a state variable. Okay, it is a state variable. That means it is in the storage of the EVM in the blockchain. So if you are using it here, if you are creating an instance for it, you have to specify where that information is locating. It is locating in the storage. That is why we are using the storage here. If you use memory, it's not going to work. It will throw you some error. So, but here, if you are passing data in the function here, you have to use memory because you are getting information temporarily that you are going to get from the user. That's why you are using memory here. Okay, so that's the difference. So now here, let us compile it again. It should work. Okay, it's showing error. What is the error here? Unknown pragma. This is the error. Let me remove it. Okay, all right. It's a warning. A warning sign. What is a warning? It said return string memory. Warning: unnamed return can remain unassigned. Okay. Okay, all right. It can here, we should not specify this return here because we are not getting anything. Okay, we are only setting this information here. So now let us create a get function. Get student. Get student. So that student is to expect an address underscore student. Okay, and it is public, anybody can call it. And this here we now specify the return. Let me now paste this one here. The return type now, what we are expecting to get. So let us create the body, and we are going to say return. Return. Remember that we create a mapping here, which is a key value pair that is representing the storage. Okay, so now we are going to be using the address here. This address now, we want to get, this is the address of the student. We want to get the details of this student. So we are going to be using this mapping name called student. Student, and we will pass in the address. You know, remember that this student, it is a reference to this storage here. This student variable here is a reference to this storage here. And for you to get this value we are concerned about, student detail. And for us to get this student detail, we need a key. And this is the key. And this key has been provided for us here. This is an address type. It has to be an address type. If you pass in any other data type, it's not going to work. So let us pass in this address, which is the underscore student. Okay, so we are going to say return underscore student. Okay, when we return this, it will return this value for us, and we are specifying the value we are expecting here. This is the value, and this is the value in the struct. These two value here that we are expecting. Okay, so let us. Okay, it's error. Where's the error there? Different number of argument in return statement than in return declaration. Okay, return students. Oh, okay, all right. I think let me remove this one. Show error. Different number of students in the okay, all right. I think I got it now. This is the mistake here. So I'm going to put it in a brace. I'm going to put it in a brace because we are getting more than one value. Okay, so now student dot what dot name then students underscore student dot age. Okay, dot age. Okay, let's see if that work. Okay, that work fine. There's telling us there's a warning function state mutability. Okay, mutability in the sense that we are not modifying the storage or anything in the contract, so we are simply getting something. So we can set this to what? To view. View in the sense that this function now tells us that this function is returning something, is not modifying anything from the contract. So when we compile it, that should go away now. So what is the error telling us? Address student, unused function parameters. Okay, the address of the student. Okay, we do not okay. I'm using message on sender here. It's not supposed to message on sender. It's supposed to be underscore student. Okay, all right, that should go away. All right, that is fine now. Okay, we compile it and let us deploy it as our last class for today. Let us deploy that. That is correct. So let us interact. Let me delete this contract. Okay, let me redeploy that. Okay, all right, so this is our functions. Now we're having how many functions? One function, two functions, and we're having the two functions basically, and this is the one function, create student and get student function. Get student and create student. The other third one is as a result of this public the visibility here. We originally we create a getter function for this. I said it many times. So now let us create a student. Let us pass in an address. So let me come here. Let me switch. Let me get another address. Let me get this address. Let me go back to this. Let me go back to this. So I copied an address. I put this address of the student, and the student name is let's say his name is Jalex. His name is Jalex, and his age of 35. Okay. All right. So let us run that. Okay, that is correct. Run perfectly. All right. So now let us get student. Let us get that student detail. So this is the student detail. Let us copy this address, the address of the student. Okay, let us paste it here, and let us call this function. Can you see now? Can you see what is returned to us? I hope you guys understand. And this is the student function. This is the get student function. We pass in an address, and this is the address we pass in here. And this is the what we are expecting. This is the type of the information we are expecting. The first one is a string, and it exists in memory, and the second one is the unsigned integer. And here we are returning the student's name. Student, this student, the reference storage, and we pass in the address. Is expecting a key as an address, and which is the worst. What is here? What changes? Okay, it's expecting this address we pass in here, and we are now accessing because of these student details we are expecting. It will now give us an access to this student detail. We can now access this name. And in any programming, when you are using dots means is a way of accessing the member of an object. That is what dot is used for in any programming language. In a lot, if not all, most, dot is used for accessing the member of an object. So whenever you specify this dot here, it means we want to access the member of this object we are passing it here, of the object here. So this student dot name, we're accessing this name here. These are the members of the student struct. They were accessing the second one, which is the age. And that is why you see it's returning the 35 for us, the Jales, and because of what we have set here already. And if you check how many students are we having now, in this list, we only have one student. So if you pass in is 0, the first index, and you click on it, it will return the student name. Because if you pass in 1, it will return an error for you. If you run it, you can see it here. It return an error, a VM error. Sorry, you see it here, VM error. So it's not going to work. But in this detail, in any array, the index of an array starts from a 0. Okay, index of an array starts from a 0 and not 1. So that is why we are using the index 0 here. That will return this detail for us. So that is all about that. So guys, anybody with question, and that should be that will be the last topic we treat for today. Somebody say I'm sweating here. Yeah, okay, it's long because I have to make it long so that we can cover it on time. Even me, I have a lot of things to do, but it's important that we give this time. All right, guys, that's the end of our lesson. Please, everybody, anyone with question, I'm open to question right now. Anybody there? Anyone with question? Hello, guys. Somebody is raising his hand up there.
Okay. Good evening.
All right. Good evening, bro.
This is Jonathan. Looking at the data structure, when we are building, writing a solidity contract, we have to put in place the cost implication of whatever we are using.
Okay.
I've read some. I've read different articles about different data structure and then the cost implication of using them, such as the array, which is
very costly.
I think they say yes, very costly when using it. So,
yes.
Is there a way we can, in most cases, bypass using an array for building a contract?
Okay. All right. Great. All right. Thank you. Like you can see in this, that's a very good question. You can see in this contract that I am using an array here. Okay, and I am using a mapping here. They are doing almost the same thing. Okay, this is a way of storing items or your data in your contract, and this is also a way of storing data in your contract. But there's a difference between them. Difference between them is that in this student array, in this student detail array, it does not have a key, and the only key that is created for use will be an index. And that is why you see from here that we are using an index. Automatically there will be an index for it. We're using the index to access it. It does not give us the freedom to specify whichever key we want to use by ourselves. That is one of the implications. That's one of the disadvantages of using that array. And here in this mapping, we can specify the type of key that we want to use. We are using an address to be able to get the student detail, but we can also try to use an unsigned integer, okay, to get this array. But here we cannot specify the type of the key. It does not have a key value pair, but the Solidity will create an automatically key value for us, which is the index. That is number one. Then number two, student array, you can iterate from this. I can use a loop. If you have hundreds of students in this array now, we can have even 200 and 1000 in this array. And for you to get, like you want to get like 10 of them or a group of them, you understand? We can use a for loop. You can use a for loop on this one, but on this mapping, you cannot use a for loop. So it now depends on the kind of contract you are writing or the kind of data your data structure you are creating. Okay, if the data structure require that you get some number of students, then you are going to be using a for loop. And if you are using a for loop, then you'll be needing this, what we call this data, this array. Okay, so but if your contract does not require you to get that large number of students, then you can simply use this mapping, and this mapping is at least a bit cheaper than using an array, because you will have to use a for loop in some cases. And here I'm not using a for loop, I'm only using an index to access it, and that is when you know the index of that value that you want to get. If you don't know the index, then you might want to use a for loop. Okay, that is the difference. I hope you understand.
Yes, I do. Yes, I do. But
Yeah.
but is there not a way whereby we can still use this mapping, and then, let's say, for instance, now we are attaching, where we have this address here, we are attaching it to an unsigned integer, and then try to write a for loop whereby we increment the unsigned integer to call to get the data and then put it inside an array in the front end.
And there are different ways you can manipulate. You can try to manipulate your code to get what you want. But let me tell you something. If you are still using a for loop, and for loop is expensive and it's very dangerous sometimes for you to use a for loop. So it's very expensive and very dangerous. So this student array, it is not the one that is really dangerous. Okay, it's costly because you have to store some data in the storage. But where it becomes more costly is when you are iterating over this array, when you are using a for loop. But here you cannot use a for loop on this one. But like you said, that you can create a kind of an integer, you can loop through them, and you cannot pass in that iterator inside this my student as a key. Okay, Abi, you first create a key here as an integer. So whatever the for loop is releasing, we are not passing it here as a key to get the details of this. That can work, okay, but you are still using a for loop. Do you understand me now?
Yes, I do. Yes.
Okay, all right, great. So any more questions? I will entertain just 2 more questions. Excuse me, guys. Hello, brother Mutalamu, I don't recall. I'm on a call. Please, I'll call you back. Yeah. All right, guys, please, 2 more questions, please. I think somebody wants to ask question the other time. Okay. All right. If there are no questions, I want to say a big thing.
Hello.
Hello, I can hear you, Yusuf.
Yeah. I just want to thank you for the class. Actually, I'm joining this class for the first time,
okay.
And I don't know if I can have access to the previous class.
videos,
So
right?
I just joined. Yes.
Okay, all right. I'll drop a link.
Because
are you on the WhatsApp group?
Yes, I just joined it this afternoon.
Okay,
I just saw the link on the Discord, on the BSC Discord, so I joined the link.
Okay, all right, great. So I will ask somebody, or some of the guys that are listening now can help us to repost it on the group. But I will drop it again on the group. I will search for it and drop it for you. Okay.
Okay. Sorry, what of the material, the slide you're using? So can we have access to it?
You mean the slide?
Yes.
Yes. Excuse me. Sorry, I am on for this tutorial. I am not using a slide. Because we are not covering much, since we know what we are already covering, which is data types.
Okay.
So we are basing everything on data types, and so I am using this documentation. Okay, so the slide is this documentation. Okay. You have to go back to the Solidity documentation. Okay. Let me get the link. Let me get the link and paste it.
I know everything regarding this one.
Okay, all right. So you can just go to that documentation and read through it.
From Remix, ba?
Yes, no, not from Remix. Not from Remix. Don't let me put it on the chat so you can copy it from there.
Okay.
So I drop it on the chat right now.
Okay. Thank you very much.
Okay, all right, you're welcome.
Okay. Thank you very much.
Okay. So any other questions so that I can just. All right, guys. Thank you for.
Just a thank you from me. Just a thank you for your time and energy and everything. It's wonderful. May God keep blessing you for that.
Amen.
Thank you for your time. Thank you.
Right,
really
guys.
appreciate you.
You're welcome. You're welcome. And let's give all the appreciation to God also. And I appreciate your time also and your compliment. And I wish you guys a good luck in this.
Sorry, please. Can we have this record?
Of course you will. Of course you will. All right. So I'll say good night, guys. So we'll meet on the WhatsApp group now.
Yeah. Good night.
All right. Thank you. Bye.
Thank you, Bob.
Thank you, everyone.
Thanks.